I'm going to explain the about the project that like how much I have understand the project and how the image flow is working throughout the app. So I think so. The this repository is a repository that has been set up to clone these repos, and then it does is deploy the Docker, and in that Docker we have multiple services deployed from these repos. All the work start with this first file, which is file watcher. So this file watcher is basically a system that monitors directories for new images files, and then it send through these images for processing to the other repositories. So the key file in this is app.ts that runs at the start. So this file is responsible for setting up the handlers and shutting down them. So there are this is the main function that is responsible to basically start the whole system or the process, we can say. And there is a service, init service, which basically starts the file processing service, and the 0mq service, which so this 0mq service is the most essential service, which does is provides connectivity between the other repositories. So this 0mq service is used throughout all the repos to make the interlinking and connection between all the files. So all the file processing start with this file processor. So in this file processor, we are doing is we are triggering the strategy of the file processing. Like there are two types of strategies basically. First is the Redis strategy, and another is file trigger strategy. So if the strategy name is not provided, it by default use the file trigger strategy, right? So we have these strategies interacting with the images folder for this images folder. So whenever the image is being placed, so we trigger an event for this, which then does is process the file according to the strategy we have defined in the system, right? After that we have this configuration file. This configuration file is basically handles the loading and validating the configurations from the environment variables. And then we have DTO file. This basically defines the data transfer objects that we use throughout the application. So the file watcher can be configured to watch specific directories like for new files and process them according to the strategy, and then forward them to the next pipeline services like these repos via 0mq service. Then after it processes the file, it then sends the 0mq service to the engine vision connector basically. So this file watcher sends a signal to engine vision connector through 0mq. So this engine vision connector is basically an agent that or you can say bridge, that is a bridge between the file watcher and the AI engine, and this is handling the main communication between the two. So the entry point of this belongs in the app.ts here. So here through the main services we are loading configurations and initializing the service of like uh, zero MQ services. So whenever an input like we get the signal from the file watcher repo, so this receives the signal through zero MQ, and then we have the engine this engine connector. What this does is basically receives the image from the file watcher, then sends them to the AI engine, then it receives the detection results and then forward the results to the post processor. So all these things are happening in this file. So here we initiate the zero MQ, then we send the event to the engine MQ connector, and then we process the event, then we generate the output file name and saves it, then we send the message to the engine. So in this services there are multiple files that are responsible to handle the services. So this receiver is basically receives the image via zero MQ, then there is this drain ZMQ service which basically sends the process result to next stage. Then there is this send status to Redis service file, which basically publishes the engine status to Redis for monitoring. So this whole service also has a mock mode, like AVC enable mock engine JSON, where it can load pre-computed engine that instead of calling the actual AI engine, so which is useful for testing and development. After this send the results to post process repository. So in this post process repository, what happens is we process the raw detection results from the AI engine sent from engine vision connector, and apply the business rules and format the streaming services. Then there is this src and app.ts. So this is the key file that starts. So it basically has the Redis service configuration and post processor configuration, and this zero MQ source which will take the input from the engine vision connector. So this is basically uh, connecting with the engine vision connector, and then there is MQ drain which is responsible for the next step. So whenever we are processing the results, and then we are sending the results to the next repository. So in this we have the post processor TS service. So this is the main service that basically processes the detection results and applies the business logic to categorize defects and formats the data for the front end. So we have all these logics handled here to process the like tile or like compute the capture results, then component results, then it scans. So all these files are here. Then we have this zero MQ source, which is basically receives the data from engine vision connector, and then we have zero MQ drain, which basically sends the process data to the next repository, which is result router. Then this Redis service, it interacts with Redis for caching and pubs up functionality. Then there is processing strategies. So these processing strategies basically contains different strategies for processing the detection results. So like we have these three types, like tile, capture, and component. And then we call this service for based on like the define what the process that we have defined basically. Which process the capture results according to basically the process we are calling from here, like process tile, process capture, process component. Then we have this router uh, result router repo. So the purpose of this result router repo is like process the results and then send to different destinations like backend image server or TCP servers. So we have this app.ts file which is responsible for initializing the 0MQ services, which is again taking the input from the previous repository and sending it to the next repository. We have this result router. So this is the main service which basically receives the processed result from post processor, then determines where to basically route the results, and basically this determines where we need to route the results and then sends the data to the appropriate destination. Then we have this MQ source which is responsible for receiving the data from processor, and this MQ drain which basically sends the data according to the payload. For like image saver, we need to send it to backend or TCP result router. After this file we have this image saver file, sorry, image saver repo. So this app.ts is basically the entry point that initialize the 0MQ services and the image saver services. So what image server does is saves the images and their inspection results to the local storage and then prepare them for the upload. So we have services defined here. So first service is image saver. So this is the main service that saves the original image. This saves the original image and then organize the files according to the configuration rules, then prepares the data to upload. Then we have this 0MQ result router source. So this basically receives the data from result router. Then we have this backend source. This basically handles the request from the backend if we are receiving any request from the backend. Then we have this Redis service. This Redis service basically interacts with the Redis for state management. After that we have this uploader. So this uploader is basically initialize the this loader is basically uploads the processed images and inspection results to basically the cloud platform. We have this key file that initialize the uploader services, and then we have like this 0MQ source. This basically receives the data from image saver. Then we have this upload services files. So it does is basically contains the services for different upload protocols like HTTP, FTP, etc. Then we have file deletion service. This basically manages the local file cleanup after a successful upload. Then we have reschedule FS service. This basically handles the retrying failed uploads. So if upload has been failed, it will automatically retry to upload the files. Then we have this upload strategy. So we can define like the strategies that where we need to upload the data. So it basically contains the different strategies for uploading the data. Then we have this assist backend. So all the work start from this main file. This assist backend basically provides the API for the front end and manages the data persistency. So this basically starts the Nest.js application, and if we'll see this app module, this has the root module that imports all the featured modules. So all these modules have been imported here to use. Then if we go to the modules, so these are all the modules that have been used in the backend. So this camera module is for camera management. So we have controllers here and the services basically. Then we have these components. So the components have the type definitions, and in configurations we have basically different type of application configurations. Then we have inspection results. These are responsible for handling the inspections and their results. Then we have image. So this image is basically for image processing and retrieval. Then we have manual inspection. So this manual inspection is basically are the tools for the manual inspection. Then we have zero MQ services here. So these zero MQ services are basically for communication with the other repos and microservices. Then we have statistics, which have uh, all the statical analysis of inspection data. Then we have Redis client in here, which is for client integration. And then we have this network, which is basically does is monitors the network. So the network like internet, it basically monitors my internet, that if the internet connection is stable, what is the speed, what is the IP and everything. So this Nest.js application is basically a modular architecture which is providing the RESTful APIs and WebSocket connection ends for like real time data sending and receiving. Then finally we have this assist front end. So this is the basically user interface, and this is the main file that started all the things. Then we have the app.txt file. Here we have defined all the structure with like paths. We have static path and a home path. Then we have this home.txt file. So this home.tsx file is the main dashboard that has the live inspection view. And in the statistics we have basically all the statical report and visualizations. Then we have components. In this component we have reusable UI components like detection score panel, header, image, thumbnail, grid, this progress bar, and these shared files. These are shared components that can be used like sharedly. After that we have these constants. Then in the API file we have this API client. which is communicating with the backend using the XCS. And in the hooks we have defined some custom hooks. So these hooks are responsible for like dragging or health checks or inspection status, network status, like this, and through which we are checking the basically networks and everything through the API from the backend. So this whole React application that provides a user-friendly interface for viewing the inspection results and managing and analyzing the data over the time. So these are all the basic parts that I have been able to understood, and yeah. So this is the whole flow of the application, which starts from file watcher and then ends with the like front end. Like all the all the services are connected with the 0MQ socket connector,